Now let's look at second problem. This problem is commonly seen in airline industry. So we have an airline called Leisure Air. They're a small airline. So for this particular airline, they have 4 daily flights. So this is a simple version. So they have one flight goes from Pittsburgh to Charlotte, one from Newark to Charlotte, another one from Charlotte to Orlando, the last one from Charlotte to Myrtle Beach. So 4 daily flights, only 4 flights. So 1, 2, 3, 4. You can see I have a direction, okay? Not our other way around for simplicity. Okay, only one way flight. Same time, with these 4 flights, they can serve more than 4 OD pairs. And the OD means origin destination pairs. So for example, with this flight, you can serve people who want to go from Pittsburgh to Charlotte. But same time, you can also serve customers who want to go from Pittsburgh to Myrtle Beach. So those people will, of course, will have to make connection at Charlotte. So Charlotte is called a hub airport. So this is pretty common. It's a hub spoke system. So how many OD pairs we have? So 4 flights. How many OD pairs we can serve with 4 flights? If you enumerate, you can see we have 8 possible OD pairs. So you can go from Pittsburgh to Charlotte, direct flight. You can also go from Pittsburgh to, which connect at Charlotte and then go to Myrtle Beach. This is second one. You can go from Pittsburgh to Orlando, connecting at Charlotte, third one. 4, Newark to Charlotte, direct flight. Newark to Orlando, connection. Newark to Myrtle Beach, connection. The last 2 OD pairs from Charlotte to Orlando, Charlotte to Myrtle Beach, both are direct flight. So with only 4 different flights, you can serve 8 different OD pairs, origin, destination. So now the question is, because the seats on each flight is limited, and the same seat can be used to serve different customers, the question is, how do you allocate seats to make most of the money? Okay. For example, a seat from a flight from Pittsburgh to Charlotte, this particular seat can be used to serve passengers who want to go direct from Pittsburgh to Charlotte. And seat can also be used to serve somebody who want to go from Pittsburgh to Charlotte, then to Orlando, right? So how do you sell all these tickets? So because different OD pairs demand different, and also different OD pairs, the price, the market price is also different. So we have to make a decision to better allocate these seats to different OD pairs so that the airline can make more money. So let's look at Excel file. Now let's look at Excel file. So this is Excel file. So these are 4 different flights. And these are the capacity for each flight. So all the flights use same airplane, 85 seats available on each plane. So these are 8 different OD pairs from origin to destination. This is the price. So if you want to buy a ticket from Pittsburgh to Orlando, you pay $228. On the other hand, if you want to go from Charlotte to Myrtle Beach, you pay $329. So this is the price for different OD pairs. This is forecast demand. Okay? Forecast demand, how many people might be willing to buy a ticket based on historical data. Now we have to make decisions. So what decisions do we have to make? How many seats we want to sell to passengers for each different OD pairs. So for example, for the first OD pair, Pittsburgh to Charlotte, based on our forecast, there will be 43 passengers who might be willing to buy a ticket. The question is, do you want to sell 43 tickets? Okay. So of course, if we have enough seats, we are willing to sell 43 tickets, but oftentimes we may not have enough seats to serve every passenger. So you may not want to sell exactly 43 tickets. You probably want to sell less than that because of limited capacity. So this is a decision we have to make. How many seats you want to sell for different OD pairs? So how many? Let's start with some numbers. 1, 2, 3, 4, 5, 6, 7, 8. As I said, the initial solution, arbitrary. You can pick any solution you want. It doesn't have to be optimal solution. So this is the number of seeds I want to sell for different OD pairs. Now, based on this solution, we want to see how many seats are occupied. So I have 4 different flights. There are 85 seats available on each flight. If you are going to sell this many tickets for different OD pairs, how many seats will be occupied on each flight? So look at the first flight. The first flight from Pittsburgh to Charlotte, 85 seats available. Now let's see. These are the number of tickets you're going to sell. How many seats are sold on this particular flight? So first of all, who's going to use the seats? So who's going to take the seats on this particular flight? If you look at these different OD pairs. So what passengers will be taking this flight? Of course, those who fly direct from Pittsburgh to Charlotte, they will be using seats here. But they are not the only passengers who will be occupying seats. There are more passengers. For example, the ones who are flying from Pittsburgh to Myrtle Beach. The one from Pittsburgh to Myrtle Beach, they have to make the connection. The first flight they have to take is from Pittsburgh to Charlotte. So they are going to occupy seats on this particular flight. Same thing. The ones who are going from Pittsburgh to Orlando, they have to make connection. So they will be sitting on this flight as well. So that's why the total number of seats occupied based on your solution will be 1. That's how many will fly direct from Pittsburgh to Charlotte. Plus 2. That's how many who will be flying from Pittsburgh to Myrtle Beach with a connection in Charlotte. Plus the ones who are going from Pittsburgh to Orlando with a connection in Charlotte. So altogether, so these 3 numbers, add these 3 numbers, that tells us how many passengers will end up taking this flight. 3 different OD pairs, but they all sit in the same flight because they all have to go from Pittsburgh to Charlotte first. So F2 plus F3 plus F4, and that's the total number of passengers who will be sitting on this flight. So again, because this is arbitrary solution, eventually the solution will be different. We don't want to simply type a number, we type a formula. Okay? So we have to link this cell with by formula to the cells. And here, this represents our decision variables. So 6 people. What about second one? Charlotte to Orlando. So who will be sitting on this flight? Charlotte to Orlando. If you look at these 8 different OD pairs, who will be going from Charlotte to Orlando? Of course, Charlotte to Orlando, the last one, direct flight. Whoever goes direct from Charlotte to Orlando will be taking flight from Charlotte to Orlando. But the question is, are these passengers the only passenger who will be flying on this flight? Of course not. Well, also, plus the ones who are going from Newark to Orlando. The ones going from Newark to Orlando will go to Charlotte first, then take a flight from Charlotte to Orlando. So those people will be sitting on this flight as well. Plus the ones going from Pittsburgh to Orlando. The ones who are going from Pittsburgh to Orlando will be going from Pittsburgh to Charlotte first, then from Charlotte to Orlando. So these 3 group peoples will be sitting on the same flight, going from Charlotte to Orlando. So it will be 17 passengers based on our initial solution. Next, who will be going from Newark to Charlotte? So Newark to Charlotte. So who will be sitting on this flight? Of course, the Newark to Charlotte, this many people. So though these people will go direct from Newark to Charlotte, that's the only flight they take. Okay, Newark to Charlotte. Do we have more passengers that will take this flight? Yes. We'll also have to add the ones who are going from Newark to Myrtle Beach. The ones who are going from Newark to Myrtle Beach will go to Charlotte first, Newark to Charlotte first. So they have to take this flight. Then make connection going to Myrtle Beach. and also the ones who are going from Newark to Orlando. The one who are going from Newark to Orlando will go from Newark to Charlotte first, then from Charlotte to Orlando. So that is the total number of passengers who will be sitting on this flight. The last one, so who will be taking flight from Charlotte to Myrtle Beach? From Charlotte to Myrtle Beach, of course, this many people, the ones who are going direct from Charlotte to Myrtle Beach. Okay, so Charlotte to Myrtle Beach, 7 people, because this is the only flight they are going to fly. Of course, we have more. Who are going to take this flight to Charlotte, to Myrtle Beach, sorry, will be the one who are going from Pittsburgh to Myrtle Beach. So those people will fly to Charlotte first, then take a flight from Charlotte to Myrtle Beach. Plus the one who are going from Newark to Myrtle Beach. The ones who are going from Newark to Myrtle Beach will go to Charlotte first. Then from there, Charlotte goes to Myrtle Beach. So that is the total number of passengers who will take this flight. So I have initial solution. I put any arbitrary number. You can put all 0 if you want. Okay. I put any number to start. It doesn't matter. Okay. It does not have to be the optimal solution. It does not even have to be the feasible solution. So I put any number to start. So with these numbers, I can fill this column with that formula. So make sure you don't just type a number, we type a formula, because these 4 numbers are not decision variables. Excel will not change these numbers, but these numbers have to be linked to the decision variables. So Excel will change these numbers. So these are, we call decision variables. Okay, we let Excel handle these numbers. So once Excel determines these numbers, so these numbers will change as well. Okay, so that's how I have to use formula. The last one we need to fill is the total revenue. Okay, so what is total revenue? If we are going to sell 1, 2, 3, 4, 5, 6, 7, 8 tickets to these 8 different OD pairs, based on this current solution, how much money can we make? Okay, how much money can we make? Of course, we need a formula, because eventually these numbers will be different. Okay, the Excel will change it. So we have to make sure this number has to be linked with these numbers to these numbers. So create a formula. So we sell 1 ticket from Pittsburgh to Charlotte. How much per ticket? That's 178. So it's 178 times 1 ticket. That's how much money we can make from this OD pair. But we have 8 OD pairs, so we have to add a second OD pair. The price for second OD pair is $268. We can sell 2 tickets, so times 2. Plus the third OD pair, we can sell $228 per ticket times 3 tickets. So we do this all the way to the end. So if you think about structure, we don't want to use a tedious way to create a formula. We have a function we just covered for example 1. So we can use sum product. This type of structure, we can use sum product. So the first parameter will be column D. That's a price structure, price column. A second column is quantity, how much you can sell for different OD pairs. So D2 to D9, then F2 to F9, 2 different parameters. So for sum product, as we know, you will do multiplication first. It will be 178 times 1, 268 times 2. Then add up. That's what sum product does. So we can make $9,878 if we do something like this. So that's how we fill the table. Now, once we have the table ready, we can use Excel solver to solve the problem. So go to data, you click data. Because solver is already loaded, you click solver. As we know, we need to specify 3 different things. The first one is your objective. What is your objective? In problem 1, the objective is to minimize distribution cost. For problem 2, example 2, what is our objective? Talk about airlines. Obviously, the objective is to maximize revenue. So set objective, I choose revenue, which is a G2. Do you want to maximize it or want to minimize? Okay, revenue, we always want to maximize it and maximize revenue. This is the objective. Second is by changing variable sales. So what is your decision? So clearly in this problem, all these green numbers are decision variables. So how many tickets I want to sell for different OD pairs, I don't know. I want a solver to figure it out. So that's why these are called decision variables. From F2 to F9, decision variables. Now the question is how many constraints we have. So what are the constraints? Let's look at the problem. First of all, if you look at flight, on each flight, I have 85 seats available. Okay, this is that total number of seats available. 85 total number of seats available on each flight. This column L, shows the total number of seats occupied by passengers based on whatever solution. Okay, so this is total number of seats occupied. This is total number of seats available. So of course, it cannot accommodate more passengers than the capacity, okay, on each flight. That means we have one constraint here. The seats occupied on each flight cannot exceed the capacity. It cannot exceed. You cannot have somebody stand in the airplane. That's not allowed. So everybody has to have a seat. So how to set up constraint? The first constraint, click add. So we want to make sure the number of seats occupied by passengers have to be less than or equal to. Okay, you don't have to sell every single ticket. So there's no need to sell every single ticket. But however, you cannot go beyond the capacity. So the number of seats occupied has to be less than or equal to. Okay, less than or equal to the capacity, which is at column K. So column L has to be less than or equal to column K. That's the first constraint. So now we have the first constraint. Do we have more constraint? I have a second constraint. So column E shows the forecast demand. Okay, that's how many people are willing to buy a ticket. Column F shows the actual number of tickets you are going to sell. Okay. Let's say if there are 43 for the OD pair 1, there are 43 customers who are potentially willing to buy the ticket. Can you sell more than 44? Can you sell more than 43? Then can you sell more than the demand? Of course not, because this is the maximum number of people who are willing to pay for the ticket. Okay? You only have 43 potential customers, so there's no way to sell more than the demand. Okay? That's why the number of tickets you can sell has to be less than or equal to the demand. You can never sell more than the demand. The demand measures the potential, the maximum number of people who are willing to buy the ticket. So that's why we have a second constraint. Second constraint says the number of tickets to sell, column F, F2 to F9 has to be less than or equal to then column E, E2 to E9, the forecast demand. So these are two constraints. So we're pretty much done. Before we solve the problem, we want to make sure we choose the right solving method. As I said, for most of the problems we cover in this class, it's going to be linear. Because it's linear, we choose simplex LP. Then click solve. So that is solution. Yeah, so that is solution. So you can see the solution says the optimal solution is sell 30 tickets. So we do have 43 people are willing to buy a ticket from Pittsburgh to Charlotte, but we only sell 30. As I said, there's not enough tickets available on each flight. So 43 people are willing to buy, we sell 30. For second OD pair, 55 people willing to buy, yes, we meet demand for everybody. Okay. We sell 55. The next one, Pittsburgh to Orlando, 58 people are willing to buy. I don't sell at all. See, I don't sell at all. So these are the actual number of tickets we should sell. Okay, so even if there are 58 people who are willing to buy it, we don't want to sell because we want to reserve the seats for a different OD pair that is more profitable. So by doing this, you can make $63,170. That's the maximum you can do. You can try different solutions if you want. You can play with these numbers. You will see you can never go above this number. That's the best you can do. If you look at these 4 different flights, you can see the first flight is full. It's you end up selling every single ticket. And second flight full, third flight full, but the last flight you still have some empty seats. So that is the best you can do. So in problem 2, we showed a different application for Excel solver in airline. It's a pretty common problem. And also, we are dealing with maximization instead of minimization in problem 1.